Okay, this is a continuation from KZN, KwaZulu-Natal, Department of Education, June exam 2021, paper 1. Yes, question 3.2. You're required to sketch the hyperbola and the exponential function. So the following functions are given. F of x is equal to 2 over x plus 2, and h at x is equal to 2x exponent x plus 2. I do not know why you say 2 to the power x when it's 2 to the exponent x. Argument for another day. 3.2.1. Sketch the graphs of f and h on the same set of x's, clearly showing all intercepts with the x's and asymptotes where applicable. Good, exactly. You see what it says? It says clearly show all intercepts with the x's and asymptotes where applicable. They're just saying that you must show them on the graph. So now we need to understand the steps to sketch. If I'm dealing with a we start with f. F is a hyperbola, right? So we need to consider this sketching a hyperbola. I can't spell hyperbola. Yes, good. It doesn't matter. The English is not important. The mathematics in this case is essential. Now, first thing I need to understand is A, right? A, because the hyperbola is defined by y is equal to A over x plus q. This is for caps for learners that are in grade 10. This is how they define a hyperbola. I'm not certain with independent boards because some educators would say they need to extend and use horizontal shift and whatsoever. But like for your level of caps, this is where you are. Now, A tells us about the shape, right? Which quadrants are we considering? Let me see. If A is negative, your function is going to lie in the second quadrant as well as the fourth quadrant. If it is positive A, your function would lie in the first quadrant and the third quadrant. This is if A is negative. This is the first thing you need to look at when you're sketching hyperbola. The second thing is the asymptotes. You have two asymptotes. That is the horizontal asymptote as well as the vertical asymptote. With the horizontal asymptote, what defines it? It's y. Y, it is equal to the value of what? Q. This Q tells us the asymptote. Now, the vertical, however, for this level, it will always be equal to 0. Now, this leads us to the third point, which is what? The x-intercept. You say y is equal to 0. Then you solve, right? When you solve, you put it into coordinates, then you plot on your function. Good. What am I saying? Let's use these steps to the given question. We are given this. The first step, I look at A, 3.2. I look at A. The value of A is greater than 0. It's positive. So I'm going to have my graph in the first and the third quadrant. I know the shape. The second thing, I need to know my asymptotes. The horizontal asymptote, Q. What is the value of Q? The value of Q is 2. So I'm going to say y is equal to 2. The vertical asymptote, I'm in grade 10. I'm doing caps. It's always going to be 0. Good. However, it will be a different thing with IEB and with other grades in grade 11 because they're introducing something which we'll discuss in grade 11 videos. Now you have the third. This is the second point. The third point is the x-intercept. X-intercept, the value of y will be equal to 0. Then I solve the equation. What is y? It's this 0 here. So I'm going to say 1, 2 over x plus 2 equal to 0. If I solve this by laws of algebra, then I multiply by 1 over 2, multiply by 1 over 2. Or I can just cross multiply, right? Which I find it quick. Cross multiply. I have negative 2x is equal to 2. Then I divide by negative 2, negative 2. My x value is going to be equal to negative 1. So coordinates, remember, 0, negative 1 is 2, 0. Coordinates are important. Now I get to my sketch. I'm going to start with the asymptotes. This is the y-axis. This is the x-axis. I start with the asymptotes. This is 2. The graph shouldn't touch this line. Then I follow with the x-intercept, which is negative 1. Here is negative 1 here. Negative 1. You will be provided with a graph when you're writing an exam. So you won't struggle with plotting. I know the shape. I know the shape. I know that it doesn't touch this line. Doesn't touch this line. I know that it also doesn't touch the y-axis because this is where x is equal to 0. And then I start plotting, I start sketching. Doesn't touch that line, but it passes through negative 1. It does not touch the y-axis. Should show this is negative 1. It should be visible. Then there it is again. It's not touching the y-axis. It's not touching where y is equal to 0. This is my f. I label this is f. There we go. Now let us get to h of x. H of x is an exponential function, of course. What are the key things to sketching the exponential? Good. Now let's look at exponential function. Expo, y, it is equal to a times b exponent x plus q. Always be considering that b carries the exponent. Always, not a. So for example, if I have y is equals to negative 2 exponent x, the value of a here, a is an invisible something, you know, then b will be 2. You see, it's not always the power, the base, it's not negative. Base is not negative. Always bear in mind that there will be a here. If I have y is equals to 2 exponent x plus 4, here a is equal to a positive 1. Then we have b being equal to 2. And then if I have, for example, now I'll be focused on focusing on now knowing the diagram. If a is positive, oh yes, very, very important. What considers the shape of the exponential? It's 2 factors. It's both a and b. Now, let's look at this. I tried to be creative and drawing perfect. As you can see, my lines are very, very accurate. Yeah, not sure if that makes sense. Yeah, I feel like it's not my strongest point. Good. Now, if a is positive, wow, this means the graph is above the asymptote. So if you can check here, both this side on this section, here, the functions are above the asymptote. They are above because A is positive, right? Then they are above. Examples of these graphs will be y is equal to 2 exponent x. A is positive here. Y is equals to 4 exponent x plus something for me. Our focal point is that A is positive and B is greater than 1. This is a function that you're going to have, right? If A is positive and B is a number that is greater than 1, this is what you're going to have. If now B, it's a fraction, like it's between 0 and 1, and A is positive. For example, these type of curves, y is equal to 1 over 2 exponent x. Do you see? Why am I saying this? Gosh. Exponent x. I almost showed you miracles there. Good. Exponent. These type of graphs. This is what you're gonna get. A, of course, A. It's invisible there. Y is equals to 2 times, let's say, 1 over 3 exponent x. Ignore this 3. All you focus on is that A is positive and B is a fraction. A is positive, B is a fraction. So these type of graphs have this shape. Do you see? These ones where A is positive and B is a whole number greater than 1. This is what you have. Then let us look at when A is negative. If A is negative, the graph exists below the asymptote. As you can see, these graphs are below the asymptotes, right? Examples of these graphs, y is equal to negative. Specifically this one, let's say B is greater than 1, negative 2 exponent x. As you can see, B, it's greater than 1, but A, it's negative. A, it's negative, B here, it's equal to 2, so it's greater than 1. This is what you have. Another example can be when y is equal to negative 5 exponent x plus something, I don't know what. But just know our focal point will be the A and the B. The A and the B. If A is negative, B is greater than 1, this is what you have here. That is what you have there. I've given you examples of those type of graphs. Now, lastly, let us say both of them, we have A being negative and B is a fraction. Y is equals to negative 1 over 4 exponent x. This is what you're going to have. Something like this. Y is equal to negative 2 over 3 exponent x, right? As you can see, A is negative, B is between 0 and 1. Here, 2 over 3 is between 0 and 1. 1 over 4, it's between 0 and 1. So these type of graphs will have this shape. So these are the 4 shapes that you have for the exponential. Now, let us get to the steps. A and B. Now, if you can look, you need to consider A and B. You need to understand A and B, right? A as well as B, right? We'll form the shapes. The second part is asymptote. You only have one asymptote for the exponential function. Asymptote, only one, which is the horizontal asymptote. Again, y is equal to q. The third thing will be what? The intercepts. So you calculate the x-intercept, right? Then y is equal to 0 here. Then you have the y-intercept where x is equal to 0. So sometimes I want to tell you something. Sometimes in an exponential function, you won't have an y-intercept, or there can be a case where you don't have both intercepts. So it's very important that you know that sometimes you're not gonna get both intercept, you only get one. Then when you're multiplying, you won't get the other one. Okay, here's what I'm talking about. Let's answer this question here. Good. Sketching this one. First, A. My A is greater than 0. It's positive. My B, is it a fraction? No. My B is greater than 1. I go to my table. I know if B is greater than 1, yes, yes, yes. B greater than 1A, this is the shape that I have. So I go back to the question. This is the shape that I have. I have this shape. And then now I look at asymptotes. Horizontal asymptote, y is equal to q. What is q? 2. I have the asymptote. Now I go to the intercept. X-intercept, I'm going to say what? The value of y is equal to 0. Let's check. 0 is equals to 2 exponent x is equal to, oh, sorry, plus 2. Then negative 2 is equals to 2 exponent x. As you can see here, there's nothing that you can do. Clearly, you don't have the x-intercept. This is undefined. This cannot be true. This cannot be true. So you don't have the x-intercept. So y-intercept. Why is this not true? Good question. Let's go to algebra. Let's speak to algebra. Let's speak to algebra. Let's speak to algebra. Here we are looking at the early question. Let's speak to algebra. Negative 2 is equals to 2 exponent x. This cannot be true. Why? Because if I have 2 exponent x, right? This, what is defined here needs to be a positive value. For example, this can be 2 because the exponent here is 1. Same basis, equate the exponents. But if it's a negative, I cannot get a negative answer, right? With a power. For example, let's say I have 2 exponent 3. Let's say x is 3. What are the chances that I will get a negative number? Right? Or this is positive for 4, 2 exponent 5, or 100. Or let me say negative 1. The answer is still going to be positive. I cannot get a negative number as from the result of a power. I cannot. Even if x, it's a negative number. Look, 2 exponent negative 100. This is the same as 1 over 2 exponent 100. It's a positive number still. So you cannot get, this cannot be true. You cannot get a negative answer, right? If your base is a positive. Thank you. Y-intercept, x is equal to 0. Then I have h at 0 equal to 2 exponent 0 plus 2. And please, there's this error that you make, man, where you say 2 exponent 0 is 0. That's not 0. It's 1 plus 2. Answer, it's 3. I put it in coordinates form. 0 is to 3. Those are the steps. Those are the steps. The shape, the asymptotes, the intercepts. Now I can go back to sketching the exponential. Both of them don't touch this. It's the horizontal asymptote. Y is equal to 2. They don't touch that line. The y-intercept is 0 is to 3. So I'm going to have a 3 here. And then my shape. Here's my shape here. I won't get confused. It doesn't touch that. Then it goes. This is H. I've clearly showed the intercepts and the asymptotes.